This is the third video about graphing polynomial functions. This video will build on the previous two videos about end behavior and x and y intercepts to give two examples of sketching graphs from polynomial functions, one in an expanded form and one in a factored form. Let's get started. Okay, let's graph the function 2x cubed minus x squared minus 8x plus 4. This is in an expanded form, and so it's pretty easy for me to see what this most influential term is to find my end behavior. Okay, this is a third degree. It's the third degree polynomial, so it's cubic. And the direction, I get that from this term, the coefficient being positive. So it's an odd degree, and so it switches in the end behavior. It'll always end with the sign of the sign of the leading coefficient, and so I'm going to end up and start down because it switches. So something about this. It will on the left will go down, on the right it will go up. Okay, that's the end behavior. The next place that I'll go, actually, in an expanded form, it's easiest to see that y-intercept. Remember that? Okay, so plugging in f of 0, and I get 4. So the y-intercept is at 4. Now to find the zeros is a little harder in an expanded form. So I'm going to think about solving this where y is equal to 0. And the way that I solve this, I get one side equal to 0, which it already is. And then I do factor by grouping. So I'm going to group this way and this way. And I factor by grouping. The GCF of the first two terms is x squared. And I get 2x minus 1. And the GCF of the second two terms, well, this is negative, so I pull out a negative 4. I'm left with 2x minus 1. And then in both terms I have a 2x minus 1, so I pull that out in front. Don't lose my 0. 2x minus 1. And then I'm left with x squared minus 4. Okay, and that, again, just so you can see this, I know we've not done factor by grouping in the videos for a while. And this comes from here, here, which is there. Okay, and I'm still going to factor a little bit more. And this becomes, it's a difference of squares. So x times x is x squared. 2 times 2 is 4, and I get plus and minus. Okay, and once I have it fully factored, then I will find my zeros. So I have, let's see, I don't really have to have a ton of space. So I have 2x minus 1 equals 0. Add 1 to both sides, and I get 2x equals 1, or divide by 2, divide by 2. X equals 1/2 is one of my x-intercepts. So I get this 1/2 right here. Okay. For this one, what number plus 2 equals 0? That's negative 2. And what number minus 2 equals 0? That's negative 2. What number minus 2 is? That's positive 2. Okay, so I get positive 2 and negative 2 as being two of my zeros. Okay, now notice that each of these have a multiplicity of 1, right? So it's going to cross the x-axis at each of those. Okay, so I need to make sure I have a path that agrees with all the things I've done so far. I would start down here, I would cross through here and hit my y-intercept, okay? And I would cross here and then cross here and go up, right? Everything there that I've done so far, the end behaviors, the y-intercept, the x-intercept, all that agrees with this particular path. Okay. Now, if you go on to study, pre-calculus and calculus, you'll talk more about the curvature of this graph. For right now, we're focused on end behavior, x and y intercepts. If you can get those, I'm super happy with where you're at so far. Okay, let's look at one more, but we'll do it in a factored form. So in this one, number 8 is in a factored form. Okay, so I'll first again look for the degree and the end behavior, but it's hard to see in a factored form. So I could expand this all the way out, but that would be more work than I need. What I care the most about is what would be my leading term. So I look at x squared times x squared. What would be my leading term if I did multiply it out? And I get x squared times x squared, which is x to the 4th power. Okay, the degree of this is 4th degree, which means it's a 4th degree polynomial. And the direction, there's no sign here, so it's going to be a positive. So it's 4th degree, it's an even degree, and it's positive, and so its end behavior will be up, up. It's somehow going to end up and up. Okay, so it's even, so it's the same. It'll end positive, so they're both positive. Okay, now I'm going to go next to the zeros because in a factored form, it's not too bad to find the zeros. So the zeros happen when f of x is 0, when the y is 0. Okay, so it's already factored for me, and I ask myself what number minus 1 equals 0, and that is equal to positive 1. And what number minus 9 is 0, and that's going to be positive 9. Now, notice, super important that you see this, is that each of these have a multiplicity of 2. Which means that both at 1 and at 9, it's going to bounce. Okay, it's going to bounce off the x-axis at each of those places. Okay, I'm next going to find my y-intercept, which is a little trickier in a factored form, but I'll keep in mind that it's f of 0, okay, when x is equal to 0. So I have 0 minus 1 and 0 minus 9. Oh, and I get a y-intercept of 81. Okay, now I'm not going to draw this to scale because that's really high up there, but I'll just pick a point up here and call this, that's 81 because I said so. Okay, so I've got to find a path that agrees with all of these things. And I'll start up, right? I'll cross through here. It's going to bounce right here, go up. I'm not sure how far up. And then I'll bounce here and then end up. Okay, there's a path that agrees with my end behavior, with my x-intercepts, with my y-intercepts. All right, this video is about graphing polynomial functions, whether it's in an expanded form or in a factored form. Thank you so much for watching.